you got 2 then. Where did we stop off? Somewhere on here. I forget. Did we do 2, 3? I forget. Where are we at? Do what? 5? So I haven't done 5 yet. Excuse me. All right. All right, so let's figure out number 5. So it gives us the original function, so we're going to want to find the derivative of it. Excuse me. Don't know what's going on. Got a little tickle in my throat. All right. So if I'm going to take the derivative, we can kind of just drop that off because the derivative of that's going to be 0, so I'm not going to worry about it. So f prime at x is going to be 2x squared minus 4x raised to the first, and then times the derivative of the inside gets to there. Hello. Any good to see you? All right, so are we good so far on the derivative? Excuse me. All right, so then we want to figure out, give all the max and mins for the following as the ordered pairs. Okay. So, let's see, how would I want to do this? I'm going to take this part and this part, set them equal to 0. So that's going to give me x equals 0. I'm kind of ignoring this right now. X equals 4. And then 2x minus 4 equals 0. So x equals 2. All right, so those are our critical values, meaning that that's where mins and maxes and all that kind of stuff can take place. So, number 5. What page are we on? What's it say? How much? 5.2 or page 61. All right. So with that note, I'm going to do number 5 down on number 6's sign chart just so I can kind of see it. So if I pick a value way over here, say pick like -10. If I take -10, plug it in, I get 100. That's 140. That's going to be a negative number. So this is going to be negative this way. If I plug that in, I got a negative value. If I plug 1 in, so plug 1 in, I get 1 minus 4. That's negative. And then, so that's negative, negative. So this is going to be positive. If I take 1 and plug it in, I'm going to get, say 1. That's going to be negative, negative, negative. So there's a positive. And then if I pick, say, a bigger number like 10, plug it in, that's going to give me a positive. Ooh. What does this problem have 2 of, for sure? Phones away, please. What do I have 2 of because I have multiple pluses in a row? Yeah. So basically this would have told us it's going to be a negative here, and then it goes positive, then it goes positive, then it goes positive. So that means this is a point of inflection here. This is a point of inflection here. So this is going to be a minimum value at 0. So if we wanted to figure out as ordered pairs, max and mins, so I only have a min on this one. So if I plug 0 in to the above equation, I'm going to get 0 for that. So 2 times 0 times the number. So I have 0 times, so 0 comma 0 is going to be our minimum value. And then we have points of inflection that are going to take place at 2 and at 4. So this would be kind of a weird looking graph. It would do this to this. So here's your points of inflection. That's what it would show on that problem. Can I clear? Good? No? Yes? Maybe? I don't know. Pause. Hey. We're on page 61 when you get back there.
Yeah.
All right, ready? Set. Yeah, no, maybe. Good. Good back there? Good, good, good. Almost.
Is that POI?
Yeah, for point of inflection. Almost there?
Yeah.
3/4 there? Good? Everyone else good? Clear. All right. So let's take a look at this F prime chart. So they gave us this. So basically, it looks like that's -2. That's going to be a point of inflection. And then we have a minimum here at 1. Okay, so if we were to set up our sign chart on this, we have -2, and then we have 1. So this would have given me a negative like that, and then to a positive, and that's what that derivative F prime chart would look like based off that. And showing at the -2, you have a point of inflection taking place. Then the next one, we have the F prime chart. So I have something taking place at 1, and at 3, and at 5. So we go negative here. So this would look something like this. And then goes to this. Wait, not bless you. So that's basically what this one could look like. That's not the exact picture, but that's, picture it, it's hopefully building in mind kind of what it looks like because of the points of inflection. Let's see, positive, negative. Oh wait, does it really look like that? Hang on, I think I goofed up on this one. All right, so it goes from negative, positive, to like negative, something like that. That's what it'll look like. I'm sorry, I had goofed it up. Can I clear? Wait. I can wait. Go ahead, Shorty. Is that what you call me? I love it. And that looks like it's the last problem there. Increasing, decreasing. All right. First thing I want to do to this type of problem is we want to take the derivative so we can start seeing some stuff. So the difference between a root and a critical value, a root is where it would have crossed the x-axis. If I asked you to do this, you have Desmos to do that, and you just figure out where it crosses the x-axis. I'm not going to worry about finding the roots on this one. We'll just cross that off for now. Polysim is, there's something on the TI graphing calculator that would allow you to do that, but We will use decimals, which is I like better. All right, so let's figure out our derivative. So g prime of x, I'm going to get 5x to the fourth over 5 plus 4x to the third over 4 minus 6x squared. You can cancel those out, which makes it a little nicer. So I get this to be my derivative. Okay, so that's what the derivative is cleaned up, which made it nice. A lot of times in math classes, if they've done it correctly, they'll make things cancel out nicely. They don't always do, but sometimes. And then what I want to do is, in order to find my critical values, each of these has an x squared, so if I factor an x squared out, I'm left with x squared plus x minus 6. This factored out is going to be x plus 3 and x minus 2. So that's our derivative factored out, which means if I do x squared equals 0, that means x equals 0. X minus 3 and x equals 2. So I have negative 3 here, I got 0 here, I got 2 here. So then we can start taking a look at it, making it like, they didn't give us a sign chart, so we'll just base off our parabola of what it's doing. Alright, so if I pick a negative 10, which is way over here, I mean, not quite that far, but just play with me. So that's going to give me, we plug that in, that's giving me 100. That's a negative, that's a negative. So a positive times a negative times a negative is going to be a negative over here. Wait, did I do that right? Hang on, I just got dumb. That's a positive. Because if I plug in here, here, and here, if I plug negative 10 in, positive, negative, negative, positive times negative is positive. If I pick, say, negative 1 and plug it in, that's going to be positive, that's going to be negative, that's going to be negative. So a positive times negative, negative. If I picked 1 and plugged it in, positive, positive, negative. So this is negative here. And then if I picked a value like 10 and plugged it in, positive, 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 so it's positive there. So this is a point of inflection at negative 3. And then we have basically that takes place, so we have a max there. And then it's going to go up here. So we'd have a min here. And then it's going forever that way up, and it's on the far left. You have your point of inflection. So this kind of goes to here, and then it changes direction, does something like that. So that's basically what our graph would look like. So critical values as ordered pairs. Let's see, I could figure out our point of inflection by plugging negative 3 in. So that's going to give me 9, 0, and 1, or negative 5. So that's going to give me 0 as our point of inflection. And then if I did my max is taking place at 2, or at 0, excuse me. So 0, we're going to have a max. So if I plug 0 into the equation, I get 0 times everything. Oh, that's kind of, I goofed up something there. Negative 1, 0, negative 3, 0, 0. Yeah, I do. So something's taking place here to give me that. I guess the max could happen at 0, 0. That makes sense. Okay, that's fine. I didn't make a mistake. I thought those were the same point. I'm being dumb. And then I can plug 2 in. That's going to give me a min at 2. So I plug 2 in. That's going to give me 4, 5. That's 20. minus 0. Oh, we got a 0. So we had all this stuff that happened on the x-axis, it looks like. Intervals where it's increasing. So it's increasing here, along here. And this line is going to keep going that way. And it's increasing here. So intervals of increasing would be from negative infinity to 2. And then from, or to 0, that's a 0. And then from 2 to infinity, that's where our graph would be increasing. It's decreasing right here, which is actually supposed to be 0 back there. So from 0 to 2, it's decreasing. And these are both increasing. Woo, baby. All right. Yowzers, yowzers. And I'm not going to worry about number 10 because I think we've kind of done one almost identical to it. Holy moly. You guys feel okay with this? Oh, I'm going to tell you what, as soon as you guys are done writing this down, I'm going to pull a blank board, and we'll hit the blank board. And you stop me when it becomes the, huh? Deal? All right, so let's kind of regroup. I'm going to go to a blank board. Put what you need to have down on paper. If you have a blank sheet somewhere in the book, that's fine. Ready? Everyone ready? 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 Freddie, Eddie, Betty? Phones away, please. All right, let's go to a whiteboard. All right, so let's say a derivative is given. And you get x minus 2, x squared minus 9, and x plus 3. Let's say we had something like that. Let's change that to 4. Okay, so this would have meant I had taken the derivative of, we already know the derivative. So, what we're going to do is we're going to set each of these equal to 0.
So you equal them all to 0?
Yeah, you're taking the derivative and you're setting the derivative equal to 0, so you're setting each part equal to 0. Good so far? We don't know what the original one was because we've just given the derivative. All right, so that basically means on a signed line, on an f prime line, we have -4, -3, 2, and 3. So basically what's happening is somewhere along each of these lines, something's going to happen. It could be a max, it could be a min, or it could be a point of inflection. Point of inflection will take place when we can have a negative and a negative next to each other, or a positive positive. Okay, so somewhere within this region, we're going to take care of this. So I'm going to pick -10 because -10 is far to the left, and -10 is easier to plug in than some other number. So if you take -10, plug it in here, -10 plugged in here, that's negative. -10 plugged in here is positive. -10 plugged in here is, so if I go a negative times a positive, I get a negative. A negative times a negative is a negative. So that means over here, the slope would be coming down until I got to -4. Now some could happen at -4 where I can keep going negative, but we're not sure. But up to -4, so something's taking place. And then it kind of gets hard to figure out what to plug in here because I did it a bit poorly, but I'm going to pick negative 3.5, which is goofy. If I take a negative 3.5, plug it in here, I get a positive. Negative 3.5 plugged in here, that becomes a positive. Should have been negative. If I go negative 3.5 here, that becomes just a negative value. If I do a negative 3.5 here, negative 3.5 quantity squared is bigger than 9, so that would be a positive value. And then negative 3.5 here is a positive value as well. Negative times positive is a negative. So that basically means at negative 4, something called a point of inflection is taking place. It's going to be coming down in a negative, it's going to flatten out, and then it's going to keep going down negative. So like right now, I know this. So this something's taking place here like that. So this is a really bad rendition of point of inflection. And then if I pick a value here, so 0 is a good one to plug in. 0 minus 2 is a negative. 0 minus 9 is a negative. 0 plus 4, so I get negative times positive, which means that here it's going to be positive. So at negative 3, it starts going up, so I have a minimum value that's taking place at negative 3. And then if I were to pick something in between these two guys, so like I'll pick 2.5, plug it in. 2.5 minus 2 is positive. 2.5 squared is 6.25 minus 9 is negative. So I'm going to get, where am I at for 2? So I'm going to get, negative, negative, and positive. So a negative times a positive is going to be positive here. So that means that I have a point of inflection here as well. And this was where the other point of inflection was. And then if I pick a number over here, say 10, plug it in. 10 minus 2 is positive. Positive, positive. So that's positive. So we also have a point of inflection here. So basically this graph would come down, over, come up, something like that. So we have 3 point of inflections and 1 minimum value. If I wanted to find where those points of inflection were happening, I can plug in those values, plug it back into the original derivative, and it'll give you the y component of it. A little different. All right, let's go back to this. Sweet. Good there. All right. So I know that on 5.3, I'm going to skip the maximizing revenue because that doesn't make sense to me. When I work the problem, the numbers are wrong. So find the absolute min or max over the intervals. So let's see what the next page offers. All right. So I'm skipping over to worksheet 5.3. I'm moving. All right, we're going to go to number 2. So this is 5.3 worksheet. It says an agency charges $10 per person for a trip to a concert. If 30 people travel in a group. Okay, so if 30 people go on this trip, it's $10 per person, so that's going to be $300 because 30 times 10. But if each person above 30, they will reduce the price by 20 cents per person. How many people will maximize the total revenue if the trip is limited to 50 people? Okay, so if we kind of step through and think of what's taking place, 30 people times $10 would be 300. And then there's a maximum of 50 people that can go. So as soon as I get above 30, we're reduced by 20 cents. Okay, hang on, but for each person above 30, the charge will be reduced 20 cents. So that basically means that if you had 31 people that went, if there was 31 people on the trip, you're going to times this by $9.80. If 32 people go on the trip, it's going to be $9.60. You know, and you can keep going and trying to plug that in to see what would be the maximum total revenue if at most 50 people went. So I could continue my list. I could go 33, subtract 20 cents, 34, subtract 20 cents. Or I could do this. Let's see. 30. How do I want to do this problem? Hang on. Stump and stirrup.
Oh my gosh. Wow.
Hang on, don't write anything down. I'm stump and stirrup.
Come on, stir up. Walk in, dude.
I'm trying. Ah! I just lost train of thought on this one. I lost train of thought. Oh my gosh. Hang on. Oh my gosh, I gotta go back to my book. I can't remember how to set these problems up. Like, how would you expect us to? I'm sorry, it was a year ago I taught this last. I forgot. Revenue. Oh my gosh, I'm lost train of thought. I feel like I'm dum-dum. 1024. We are definitely not doing that. Okay. Revenue. almost there. Shoot. All right, I think it's done this way. So you have kind of two revenue equations. So if I do 10x times 30, and then minus, talking 20 more people, so this is going to give me 300x minus, that gives me 9.8. 9.8 times 20. 196 minus x. I'm going to skip this problem. I don't like this problem. The stirrup got stuck. I'll go research it. I'll go research it later. I'll take care of it. Oops. All right. What do we say we try a non-word problem for tomorrow? You try that one right there. Don't worry about the bound -1 to 3. Just do the derivative and try and get the sign line out of it. And I'll figure out what these word problems are. I know you guys are excited about word problems. I know I'm not testing on word problems, so that's what we'll call it good there.